way to do this, to break these videos into individual videos. Otherwise, you wind up 7 hours long, and that's not good.
I understand. Yep. Test.
Okay. Well, we're just going to make do with it, and we'll just go from there. Okay, at this track, we're going to have making printed circuit boards the easier way. And so, Gordon, you should be able to share. I have it turned on where you can share your screen, and I'll turn it over to you, and you can pick up the presentation.
All right. Is there a member of the audience who could say something so I can tell whether or not I can hear you guys?
Test 1, 2, 3.
All right. If you're loud, I can hear you. That sounds great. Okay. So this is a talk on making printed circuit boards for your group or your project. I've got all of my kids and all of my grandkids over today, so there may be a additional participant show up at any time, possibly 3 feet tall. So we'll see what happens with that. And if there's a problem with the audio or something else, just go ahead and flag me down and we'll deal with it. So the first question is, why would we, let's see, slight podium sound loop on Zoom, but it's understandable. Why printed circuit boards? Far easier than perf board point-to-point construction. Our experience is you will build things 4 times faster, quite literally, if you provide your group with printed circuit boards. It's an astonishing reduction in problems, and you're going to have much more fun doing it. It's so much easier that now sometimes for a simple project, I won't even breadboard it. I'll just have the boards made in China, and 6 days later I can build the thing, and if there's a problem, I could make a small adjustment to the circuit board with a jumper or something. You can get much better circuitry than what you can do with perf board, because you can build in shielding, you can build in ground plane capability. You can even use, you can provide shielding, you can provide places where you can solder in a double-sided circuit board on edge to provide edges to it. You can make microstrip lines. I learned the other day what's the secret to make a 50 ohm microstrip line. I never knew that before. You can have very, very thick traces. You can ask for 2 ounce copper, so you can have very high capacity wiring. We've got some boards that handle 20 amps. It allows your builders to focus on the parts. They don't have to work so much on how to position them. It supports the parts very well. You can even have a circuit that has mixed surface mount and through hole. Surface mount components are getting harder to find, so you can use some of the larger, excuse me, I said that wrong. Through hole components are becoming harder to find, so you can have some surface mount components in your project if you'd like. You can build them as big as you like. You can make as big a pad as you want. Remember, the only thing we're doing is putting copper on a board. It's what you solder to it that counts. Why would you want to build stuff? Well, in our group, it's basically an anti-Alzheimer's activity. We use it to keep people stimulated, to teach, to bring up new things to do. It's way cheaper most of the time than buying stuff that's made commercially. It allows people to learn how to repair their own gear. Great group building opportunities. So we tend to get people together on a Saturday afternoon after a lunch at a fast food place. We put some cardboard on the top of a dinner table and we haul out the soldering irons, and people will spend the next 3 hours building, and they just have a blast. It's, you know, there's a subgroup of the group that enjoys this, but the subgroup just has a ton of fun with this. What to build? Oh, there's just no limit once you get good at this. So we typically will build sound card systems for older radios, and we can do them for $20, $25 instead of paying $130 or $140 for a signal link. You could lay out directional couplers for almost any frequency range you could think of, because you can control the geometry. So you can make antenna projects. You can make what we call a polarity protector. We have one member of our group who has the unfortunate history of destroying 2 expensive HF radios. But we have a MOSFET circuit, there's a schematic up there, that allows you to basically interrupt the wrong polarity of current, and it simply won't destroy anything. You can make common mode current meters for your antenna project. You can make tiny receivers, transceivers, QRP rigs. You can even make solid state linear amplifiers, bench power supplies. One of the early projects we did was sort of a lightning arrestor, EMP protection. We could do that easier now, perhaps with a printed circuit board, because you can mount the connectors right on the board. We have a school receiver project. I'll probably tell you more about that in this talk. That has been just a ton of fun and a huge learning project, and we used it with our extra class course as well. Turns out the biggest problem in building is getting enclosures. You have to kind of get creative, because enclosures are not that easy to make yourself. For things that don't need to be shielded, we will often use electrical boxes from the hardware store. They're dirt cheap, $1 or $2, and you've got your enclosure. They're easy to drill in. You can also use metal tin boxes. I gave you a link there to specialtybottle.com. They provide just about any kind of tin, cookie box, cookie tin that you would want. You can get modeling plywood, real thin plywood, 1/8 inch, 3/16 inch, and glue it together to make a box. Tin boxes that you get at Christmas, you can turn those into enclosures. There's a growing number of enclosures that are sold from Asia, US Banggood. I gave you a picture there of what looks like an instrument case that you can build a transmitter transceiver in. You can also use surplus radios that don't have a huge amount of value left. This is a project that I laid the board out for, I guess about a year ago. And we've now built about 5 of these. We have 6th and 7th graders building these. We have 70-year-old people taking the extra class course building these. It's an entire, very accurate frequency, but very simple receiver, direct conversion receiver. I stole a lot of the ideas from my good friend Asher Farhan, who designed the MicroBitX. It has power supply sections. It has power amplifier, preamplifier, balanced mixer. It's got a microphone built in, so you can use it as a small public address system. It's got an Arduino, and it's got a SI5351 chip, so it's rock solid on the frequency. And I've created the entire kit, overview, instruction parts, bill of materials, Gerber files, Arduino sketch. Everything is available on our website, qsl.net/nf4rc, under the educational articles page, under school radio kit. So it's a ready-made project just waiting to be built by any group that wants to get a ham club going in a small school. The 6th, 7th, 8th graders had just a blast soldering. I let them do the top part, the receiver part. They learned how to wire the toroids. The bottom part, the Arduino part, I did myself. Some of them I socketed the Arduino, some of them I was brave and I soldered the Arduino, but just lots of ways you can do this. The Polarity Protector Kit, we built about 20 of these in small plastic electrical boxes. Those are the Go boxes that our county provides. We have about 100, I think we have 125,000, I forget the exact number, but around $100,000 of these boxes. And we were terrified that we would destroy some of the radios in them with someone accidentally connecting a battery backwards in haste during a hurricane. So we added polarity protectors to at least 11 of them. So those are very protected. Here's an example of the polarity protector. What you see on the top is a screenshot of when you're building the printed circuit board layout, and what you see on the bottom right is what the printed circuit board actually looks. So it's a double-sided board, and what you're looking at is the top trace, and there's another trace on the bottom. The components, it's a very simple circuit, are on the bottom left. And we had just absolute beginning people solder some of this together. The wiring turns out to be a little more difficult because I didn't make quite big enough holes for the wires, but we managed to pull that off too. So there's just an incredible number of circuit board manufacturers out there. In America, there's one called expresspcb.com, but it turns out they're terribly expensive. And there are some competitors in the United States, but they're also very expensive. If you are willing to use China or a third world developer, they're dirt cheap and shipping's easy. The one I tend to use is PCBWay.com, and I'm going to try to walk you through how to do that today. With DHS shipping, I get my boards in 6 days, and you just can't beat that. It's just so cheap. These vendors now have come up with shared projects, so you can make your project shared, and that means other people can just order the board. So ARRL lots of times has trouble making boards available to people, and they've had to go to great lengths to do that, but you can just pick a project and say, make me 5 of those boards, make me 10 of those boards, whatever. They're so cheap. This is a screenshot of the PCBWay front page. And basically what counts on the board is what size it is, and do you want any fancy layers or anything like that. I always build a 2-layer board with 1 ounce copper, and my boards are typically, the size of a playing card or something like that. So I can get 5 boards built, sometimes $10, and then the shipping is $25, and I'm done. It's all done. And the amount of time that I save. So the purpose of this talk is to get you set up to be able to use this kind of service. And the price has gone up just a tiny bit, but I used to could get 10 boards for about $25. You may have to pay $35 the first time now. I don't know. The price has gone up just a little bit. There are so many different layout programs out there. I discovered there's scores of them. The one that I know how to use or barely know how to use is DipTrace. So that's the one that I'm going to talk about. There's a free download. The free download will allow you to have up to 300 connections. I've only come close to that once, and I was able to get way below it by simply getting rid of some of the excess things I had on the board. There's just so many others. A lot of people use KiCad. There's a zillion others. I gave you a link here to a review of like 60 different print circuit board layout programs. I always use a 2-layer board. You can do auto layout from the schematic, but I'm just not that good at using their schematic programs, which are built in. So I usually just route the board myself manually, and it's quick enough that I can get it all done. You can do copper pours, and we'll try to show you how to do that also. So what I'm going to do is I'm going to go through this first with slides, and then I haven't done this in months, so I had to spend a few minutes reteaching myself how to do it, but I'm going to try to actually run through it. Sounds like the natives are going to make a pass through here. I think they're heading for the 2nd floor like a herd of elephants. So the first thing you do is you lay out your board outline. There's an icon for it. You left click on each corner and then hit enter to finish. The program will tell you where you are on the board, so you can use that to try to figure out your size, how many inches or whatever. Or there's a dimension tool that you can use to measure it. You can change, I think, most of the stuff later if you need to. So when you start off, you get this purple outline, which is where your board's going to be, and you get to pick which colors you're going to use. So there's a lot of different parts to a printed circuit board. So there's assembly markers of where things are going to go. There's silk. That's the colors that people can actually read. That's where you can put writing to tell them what the component is or who made this board or what goes where. There's the top mask, which I don't pay any attention to. The top paste, which I don't know anything about. And the red is the top copper. That's what counts. The green is the bottom copper. That counts also. And then it looks like there's paste, and then there's mask, and then there's bottom silk. But I never do bottom silk. And I don't board outline those other things. You can change the colors, but I always just stick with the basic. So on this, let's see, y'all can see my mouse. So this little red arrow here determines where you're going to stick things, components, or traces. So it's important to watch that one. And then I don't remember what this is for, but I think it's which one you're going to see. So usually I'm looking at the top and placing stuff on the top, but when I switch to doing traces on the bottom, you'll see I have to change that. So this is built for professional people, and so they actually have individual components that you can buy from manufacturers, and they have them marked with manufacturers' numbers. But I don't need that. All I need are capacitors, resistors, transistors, and diodes, and all I'm doing is laying down copper. I don't really care if it is exactly the outline of what the manufacturer wants it to look like. As long as I can solder the pins to it, I'm happy. So there's discrete components, there's transistors, there's diodes. You have to deal a little bit with some libraries of parts. And sometimes manufacturers will have a library for all the stuff that they can sell you. You're going to have to do a little work to find the stuff you need, but once you find the basic components, you're just golden. You just keep copying them. Once you find a set of pads that do what you want, you just keep using them. It doesn't matter if they were made for something else. If they put solder terminals where you need them, that's all you care about. You can modify, you can even create a template, and you can buy or get free other templates. So in this slide, what I'm doing is I'm putting components on the top side, and I think this was done a while ago, and I liked the layout better then than what I uploaded recently. My computer crashed, and I had to reload everything, and I don't think it was as nice afterwards, but still works. I switched to the bottom side of the board, and I manually routed a trace. You can see the trace goes from here to here. It's a green trace, so we know it's on the bottom. Then I switched back to the top of the board, and I laid out a trace here, and you can see there's a trace that goes, it's red, so we know it's on the top of the board. The yellow is screen print. That's actually going to be white or yellow, depending on what color I tell the manufacturer to make the screen print. And I can also put text in there to tell people how to do things or change values or whatever. So there's some text that I stuck in. The really neat part is copper pores. And this is where you can throw in a ground plane to your circuit, so you can make your circuit sort of self-shielding. And you can make it to where it automatically doesn't connect to the things that you don't want it to touch. And you can also make it so that ground components are automatically connected to the ground plane. I'm going to try to show you how to do that in a minute. So this is just a description of how to change the properties of the pore. You can turn the pore on, you can turn the pore off, and it'll go right back to where it was when you want it back on. So here you can see that I've connected the pore to that terminal, and I've done it through thermal connection, so it's easy to solder. You can still solder it. It's got some thermal resistance there, but it's going to make good enough electrical contact that you can do it. Let me see if I can quiet the natives down. Hey, can y'all be just a little quieter? Hey, adults, can y'all be just a little quieter? Okay, so I tried to ask them to be a little quieter. Okay, so the design rules is really cool. This will check for anything that's shorted out or too close beyond the ability of them to build it. And this is the same test that the manufacturer will do. And so you can do it for yourself, and you can find out if they're going to like or reject your board. If you get no errors, that's great. Yeah, they're making more problem than the kids are. So what you're going to do to get this over to China is you're going to export it as a Gerber file, and that's universal for most free construction software. They'll export as Gerbers. This particular dip trace is kind of screwy because not only do you have to export all these little bitty files, there's like 11 of them, but you also have to go back and tell it you want the drill symbols. And I don't know why, but if you don't do that little extra step and export the drill symbols, it doesn't work right. So what I do then is I zip everything that I built all together in one zip file, and then I just upload it to PCBWay. And once I learned how to do that, I've had no further problems. They are always very happy with my stuff because I've already checked it. You can see me here zipping it. And then I just go to their website and tell them what size the board is, tell them it's a 2-layer board, take all the other defaults, upload the zip file. They will usually take about 12 hours to review it, depending on whether or not it's a holiday or overnight or whatever. And if it's a missing file, they will ask you to provide them whatever they're missing, or if there's a problem, they'll tell you where the problem is. And then you pay them, and I only use PayPal. I don't use credit cards. So that's the only way I trust to pay them. So I've just done all kinds of projects this way, and I've even published books of how to build the projects, and that's really easy to do with Kindle Direct Publishing. And so I've got books all over the internet, dirt cheap, if you know, paper or Kindle. This is one of the first things that I did was a sound card interface. It's gone through about 3 different versions, and it basically separates the ground from the radio side and the computer side, and it also provides the push-to-talk side. And it's got audio transformers, which are, let me find my mouse. There's an audio transformer right there. You see, I couldn't find the right thing. The transformers I found had 6 pins, so I just put X's by the parts that you don't need, because you only use the outer ones. And here you can see a potentiometer. And these are just connection pads. I just stuck connection pads, so you've got more than you need. There's a capacitor. There's a resistor. I found this long little thing here of pads, and that worked fine for me to put my little reed relay on. Here you can see an LED. There's a transistor. There's a big electrolytic capacitor. So it took me a while the first time, but it's been through multiple. Here you can see one addition of that with a cheap dongle sound card connected, and you see the transformers. And this one's inside of an electrical box, so it gave it some shielding, a steel electrical box. I designed a board to fix some of the relay problems of one of the microBitX versions, and I just laid it out and had it built, and it worked fine. This was a Raduino. There was a shortage of Raduinos at one point, so I just designed my own with an Arduino and SI53, and it makes just a great variable VFO. You can buy these kinds of things, but I built it to also be an SWR meter, so I put some inputs where I could amplify inputs from a directional coupler. This was a board that it didn't turn out to get as used as I thought it would, but it was supposed to be an electronic keyer, tuner, all kinds of things, and it hasn't gone as far as I wanted. But it allowed me to build another project, which was a automated battery charger and also switcher between battery and AC supply that would switch instantly. Okay, so I think that's. Oh, let me check for a second. Yeah. Okay. So now, how do I do this? I want to do this, and I want to start sharing on this other computer. Okay. Now I want to share the screen. Let me see if there's stuff in the chat, because I can see the chat. Share the screen.
No, no question.
I heard a question.
No, go ahead, Gordon. No questions in the chat.
Okay, good. Okay, now I want to find the program. Okay, now I want to make this be small. Okay, can you guys see this circuit board? I think you guys can see this circuit board. Okay, so I'm going to move myself over, and I'm going to try to make a new circuit board. I don't know if I can do that or not, but heck, I'll give it a try. So one of these things is place board outline. So I'm going to draw the top edge of the board. Okay, yeah, I gotta hit enter. Okay, there's my board outline. And now I'm looking, where am I? I'm on the top side, and I want to be top silk, top assembly, and I want to be looking at top. And I'm going to try to put some components in. There's a little thing here that looks like an integrated circuit, and it allows me to put in components. So I want to put in a 3904 transistor. I'm too high up. Okay, there's a 3904. Think. think. So I got some transistors, and I think I can rotate these anywhere I want with the R key. So I can rotate them. I can also copy them if I want. I can copy that thing, paste that thing. So now I got more transistors. So now let's see if I can find, maybe I can find a resistor. Oh, there's some capacitors. Oh, it's like a capacitor. All right, a big capacitor. All right, I got some capacitors now. Okay, now let me see if I can find. Ooh, that's making more sense. Oh, hey, I understand what that is. That's a resistor, a big one. Oh, heavens, I got resistors. Let me see if I can find smaller resistors. Oh, yeah, I got small resistors now. All right, so now we've got a lot of stuff now. So let's start. Here's my arrow button, and I'm going to go back to just being an arrow. Now, this, I think, is the manual route button. So I'm routing on the top right now, okay? Everybody get that? So here I'm going to route top, and I'm going to route top, and connect that to that, and then I'm going to connect this to this, connect that to that, and then I'm going to go over here, and I'm going to go over here. Okay, that's good. Now I'm going to put some stuff on the bottom. So I'm going to go to the bottom. Now I'm looking at the bottom of the board, and I'm going to connect this to this to this. Oops, that one didn't work. Let's do that. Okay, and then I'm going to connect this to this, and then connect that to that, and I'm going to oops, get out of there. All right, so I didn't know how to do that. So now I'm going to connect this to this, and I want this to be a ground. So I'm going to connect this to this, and I'm going to connect this over here, and then I want it to go up right there. And I want this to be ground. Okay, so I go look at it, and I ask, oh, this is net 6. Right here it says net 6. Okay, so I'm going to remember that net 6 is part of ground. Now, I'm going to put in a copper core, if I can find where the thing is to do that. It's one of these buttons. This one. Remember where the copper core is. Objects. Place copper core. That's good enough. Okay, so I'm on the bottom. Let me do, look at the bottom. I don't know what this is. Oh. I'm going to put a copper core. The copper core works very much like the board outline work. Be nice if it was kind of straight, huh? A little spiffier. All right, so now I got my copper core. Okay, now this is my choices. So I can make my fill on my copper core be anything I want, but I'm going to make it be solid. And I'm going to ask for a good bit of clearance, okay, on my copper core, and I'm going to ask it to be poured. And look, it's already there. There's my copper core. But remember, I wanted this to be grounded. So I'm going to go back, and I'm going to ask this to let me see the properties of my copper core, and I'm going to look at connectivity. Well, it's not connected to any nets. Remember, I had memorized that net 6 was what I wanted to be grounded. So, and I can pick my thermals, what kind of thermals I want. Spoke width I can pick, and my current state is poured. And look, now those parts that were grounded, they're now connected to ground, and I can tell they are because when I touch one of them, you can see those are all connected to ground. And now I'm going to go back and I'm going to look at the top of my board. At least I'm going to try. And now you can see the bottom 4, and you can see that those are connected together. And I'm going to try to do one of these buttons is to put in text. Okay, so text. And I want to be looking at top silk. Okay, so now I put in some text. And so I think that kind of gives you an idea. I can change the magnification of this thing. My screen is not normal sized, so I tend to do things with a higher magnification. But you can do measurements on your board, and you can find out how big your board is. You can see if things were the size you thought they were. Let me see if I can do that. What are these buttons? Oh, maybe that one. Well, it didn't work. Well, darn it. One of these buttons lets you measure, but I forgot which one it is. But you get the basic idea. Okay? And now I'm worried that if I have these two projects here, I'm gonna get myself in trouble. So I'm gonna go over here and I'm gonna try to destroy this whole project. No, I don't want that. I'm gonna try to destroy this whole project and see if I can do it. I did it. Oh, that's so good. Destroyed the whole project. Okay? And then looks like I had a mounting hole here. So I'm gonna stick the mounting hole in. And then we'll tell let's see if I can find the pour. I'm gonna go look back at the pour. I'm gonna do on bottom, and I'll do the pour, and I'm gonna tell the pour to be unpoured. Okay, I'm gonna try it again, see if my mounting hole stayed there. I'm just curious if I can get that mounting hole do the right thing. Yep, now I've got my mounting hole. And you can make your mounting hole be connected to ground if you want or not. It's up to you. So now we're going to save this thing. I'd already given it a name, example board number 1. And now we are going to export and gerber. Export all. I don't know what they, oh, look at that. They changed this. They now have a way to do the gerber plus the drill. I don't even know. I've never tried that. I'll just do it myself. Because I've never tried that new trick, and I'm going to do it here on the projects. Projects is where I want to be. Go find projects. And this is TECHCON. So look for TECHCON. TECHCON 2022. Punch that button. And I'm going to make a new folder. Where'd it go? Here it is. Gerbers. Okay, I'm going to go in there. I'm going to say save. 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 How do I do? Shift just. I don't know why, but it's making me do every one. That's okay. I can at least see that they're being done. Okay, and then I want drill Svmbols. Export line. Okay, it's going to take care of some things I don't have a clue what I'm doing. Okay, so that's all done. So now I've got my gerbers, and then I will go find here, and I'll take it. Oops, that's not what I want. Click that. Click everything. Send to zip file. Done. So now I've got my entire thing is all zipped up at 20 kilobytes, and I can go to see if they're open. Get out of there. Can't see the screen. On my screen, I can't. Here, I'll drag this down. Yeah, now I can see it. Okay. And then we'll go here. PCBY.com. And man, this is hard to read. Let's make this a little bigger. Let's see if they know me. Yeah, they know me. Bingo. All right, so I have no projects under review, no projects awaiting payment, no projects awaiting completion. and I have a bunch of orders that I've made with them in the past. If I want a new order, I can click this thing for instant quote, and then I'll go through the online quote, we upload the gerber, the order review, and then I send them money by PayPal, and then they make the thing in 24 hours, like 6 days to deliver it, and we're done. So that is basically how to do it. So now I go back to this computer and bring up Zoom again. What did I do? That, no, not that. That. And then I'll make this bigger. And I ask if there's any questions. So, any questions?
Anybody questions for Gordon? All righty, I guess we will. I'm going to see if there's any in the chat. I don't think so.
Nope.
Nope, no questions in the chat.
Well, so once you learn how to do this, I mean, it takes a little bit of setup at the first, but once you learn how to do it, you will never, ever build a breadboard again. This is so easy.
Oh, yeah. That's it. Like I said, I've got a bookmark and go back and look at the links because I want to do some prototyping. It'll be a way to, I bought a CNC milling machine, but this might be a way to get, once I get past the first one, might be a way to get some production runs.
Oh, yeah. And, you know, all the cost is in the setting up. So when you go from 5 boards to 10 boards, it's like they add $10. It's nothing.
Oh,
My
wow.
general cost is a couple dollars per board.
That's
They're
amazing.
just so cheap.
That's dirt cheap.
All right. I need to unshare on some computer. It's not that.
If no one has any questions, we're going to end the YouTube part of it. We'll just leave it on here while you're unplugging stuff, and we'll take a break here and come back for our last presentation. We'll go ahead and start getting set up for that. I'll get Gary's slides up for that. It'll be interesting. Okay, let's go ahead and end it now. And